Alright, so in this video we're going to be looking at this new custom cell phone charger that I put together recently. It uses a 5 volt power adapter rated for 1000 milliamps capacity, or 1 amp, and I have the output connected to the input inside the circuitry in this enclosure box here. And the output of that goes to this micro USB adapter for charging my phone. So inside this plastic enclosure box we can see the circuitry, which consists of a Batcus board. This is a standard step-down converter module, which takes in the output as the input and outputs here to charge my phone. So the way this step-down module works is it takes in 5 volts signal here to the input and converts that 5 volts down to 3.7 volts using this wiring configuration that I've put together here. And this successfully is enough voltage to charge my phone, and the board is rated for 3 amps in total, so it can take that incoming 1 amp and easily convert that down to 500 milliamps or so. In essence, this board is a DC to DC voltage regulator with a fixed output signal. The short connecting voltage adjustments here ensures better output accuracy. And this N-type chip here ensures high power conversion. The vast majority of other components that are used are the surface mount capacitors, as well as the surface mount resistors, and this inductor right here. And here you can see the LED indication for the power supply, and here you see a similar red LED for indication of charge. So here you can see we're currently sitting at 56% of charge, and based on this battery's history on this phone here, including using this charging setup, we see a fairly steep but relatively stable discharge here, and then it drops down a bit and it goes up and down, up and down, up and down, up and down, and then it levels off a little bit here for a little while before it was about to drop down again. But I've induced a charge here. You can't really see it right now, but we should see a charging rate or incline that's going up fairly steep, and at some point it should level off at the top here at peak 100% charged, where it will then over time discharge slowly and drop back down again. So anyways, it should take approximately a couple hours from now to reach 100%. So again, this is a gentle way of charging your phone, and here we are sitting at 94% charge. And as predicted, we have a steady and balanced uphill incline here. And this slope here is going to average out at some point and discharge. So yeah, this is looking good from here on out. And here we see the green LED indication, which is indicative that the charge cycle is completed to 100% charged. And here you can see that stable cutoff point there at the 100% charge point. So here you can see we have started our discharge cycle starting at 100%, and here we see a relatively stable discharge, and we should see that curve start to come down after about 15 or 20 minutes of operation. And here you can start to see at 96% that gentle slope going down here. Now of course this all comes down to the usage of the phone in terms of discharge cycles. So if I use my phone regularly with the screen on, the discharge cycle will slope down a lot quicker. But if I leave it on idle mode, it will discharge a lot slower. Just a general rule. And here we see the first major drop-off point during this discharge cycle at 92%. Alright, after using my phone for a fair bit, we can start to see this discharge slope coming right down here at 82% charge. And yeah, so that pretty much sums it up. This is a gentle method of charging your phone using this charger here. So not only is the charger good for charging overnight, it's also good for charging during the day as well. So overall, I think this is a relatively good and safe AC to DC indoor charger, specifically for charging your cell phones, and it's great for charging for overnight purposes.